Alright, so what if I asked you how many quarters are in $2? Well, some of you can probably just figure it out right away by counting it. If you counted it, you would have 8 quarters in $2. If you wanted to express this mathematically, you would have to use fractions by taking 2 divided by 1/4 because a quarter is worth 1/4 of a dollar. To find that amount, you would basically multiply 2 times 4/1, which is the reciprocal of 1/4, to get 8. Now if I asked you how many quarters are in $1.50, you could count, but if you wanted to do it mathematically, $1.50 is equivalent to 3 halves. A quarter is still 1/4. To calculate that, you would just have to multiply the top by the reciprocal of the bottom. This is what we call a complex fraction. So, like I said, you can divide the two fractions by multiplying the top fraction by the reciprocal of the bottom. So 3 halves times 4/1 gives us 6 quarters in $1.50. Section 5.7 is complex fractions. And how are we going to simplify complex fractions? So, that was one of the methods. We're going to learn another one. A fraction is a complex fraction if its numerator or denominator or both has one or more fractions or powers with negative exponents. Remember, any power with a negative exponent is a fraction. For example, x to the negative 2 power is equal to 1 over x squared. So there are two methods to solving complex fractions. The first method I already showed you. Simplify the numerator and denominator separately and then divide. And often division means you multiply the top by the reciprocal of the bottom. The second method is by multiplying the numerator and denominator by the least common denominator of all the fractions appearing in both the numerator and denominator. So you can use either method. By looking at the problem, you'll be able to tell which method is easier to use. So we're going to go through several examples, and I will be using both methods for both of them, and you'll eventually see some patterns as to which is better to use when. Example 1, we have 3/4 minus 1/8 in the numerator and 2 plus 1/12 in the denominator. Using method 1, we would basically just divide the top fraction by the bottom fraction. Of course, you have to simplify both fractions, so use the least common denominator. By this point, you should be able to do this, so I'm going to move quickly. 6/8 is 3/4 minus 1/8. 2 becomes 24/12, so our common denominators are 8 and 12. We simplify those expressions to get 5/8 divided by 25/12. Now, when you divide fractions, you remember you multiply the first fraction by the reciprocal of the second. So we would write it as 5/8 times 12/25. If you do that, you get 60 over 200. Don't forget to reduce your fractions. That becomes 3 over 10. So again, using method 1, simplify both fractions, the top and the bottom, and then divide them, which usually involves multiplying by the reciprocal of the bottom. If we use method 2, you are basically going to multiply the top and bottom by the least common denominator of all the fractions. So we have a 4, we have an 8, and we have a 12 and a 1. The least common denominator of 4, 8, and 12 is 24. So we're going to multiply both the top and bottom by 24, which now means 6 times 3, because 24 over 4 is 6, 3 times 1, because 24 times 8 is 3, and 24 times 2 is 48, and 12 times 24, 24 divided by 12 is 2, so we have 2 times 1. So all I did was knock out the denominator on both the top and bottom. So this simplifies to 15 over 50, and again, you reduce your fractions to simplest form. Again, you get 3 over 10. So either method works fine. Numerically, it often doesn't matter. It often doesn't matter if you just have numbers, because numbers are easier to work with. Negative exponents. If a complex fraction has powers with a negative exponent, you must first rewrite the power using positive exponents. So let's take a look at how that works. Example 2, we have r to the negative 3 plus s to the negative 3 all over r to the negative 1 plus s to the negative 1. So again, let's start with method 1. Of course, the first step we have to do whenever you have a negative exponent is to rewrite each negative exponent as a fraction of the positive. So r to the negative 3 becomes 1 over r cubed. s to the negative 3 becomes 1 over s cubed, and so on. So if we use method 1, we are going to, again, you have to put a common denominator for the top and the bottom. So we have s cubed to the top and bottom of this fraction, r cubed to the top and bottom of this fraction, and we have rs as the common denominator here. So you express it as s cubed plus r cubed over r cubed plus s cubed over s plus r over rs. Again, what we're doing here is just adding the fractions together, which involves finding the least common denominator for these two fractions and these two fractions. Now we have to multiply the two fractions together by taking the reciprocal of the second. So the first step, divide the two fractions, multiply by the reciprocal. So we flip over the second fraction, that one that was in the denominator, and you get this mess. S plus r times s squared minus rs plus r squared times rs all over r cubed s cubed times s plus r. Well, the s plus r's cancel out. The rs here reduces this to r squared s squared. So your answer is s squared minus rs plus r squared all over r squared s squared. So again, with method 1, you simplify the fractions in the top and the bottom, and then you divide them by multiplying it by the top by the reciprocal of the bottom. And sometimes you can simplify just like you do with numbers. If we use method 2, again, we start at the same place. Now what you do is look for the least common denominator of all four fractions here. So the least common denominator would be r cubed s cubed. So we multiply both the top and bottom by r cubed s cubed, which means you have to use that on every single term. So r cubed s cubed times 1 over r cubed becomes just s cubed. This one becomes r cubed, and the bottom becomes r squared s cubed plus r cubed s squared. Now you're going to have to factor again. The top is a sum of cubes, so you can factor that as s plus r times s squared minus rs plus r squared. And the bottom, you can factor out an r squared s squared to get an s plus r. Well, that's convenient. Those two cancel out again, and you're left with the same answer we got in method 1. So I think method 2 was easier for this one because you have a lot of common factors in both the top and second fraction. But you can use either method, and a lot of it depends on which letters or numbers you have in the numerator and denominator. So you can choose either one. It doesn't matter as long as you come up with the right answer. Example 3, we have that expression up there. You notice again we have fractions on the top and the bottom. So go ahead and try to do this one using method 1, and then we'll come back and try to do it during doing method 2. So pause the video, and when you're ready to start, resume. Alright, so again, the least common denominator of the fractions on the top are x squared. So I converted each one to a fraction of x squared. So x squared over x squared is 1, 3x over x squared is this one, and 2 over x squared is that one. You convert the bottom fractions to x over x plus 2 over x. Now we just add all that together, and you get x squared plus 3x plus 2 over x squared all over x plus 2 over x. So we are going to divide the fractions on the top and bottom, which means we have to flip the sign and flip the fraction. So x squared plus 3x plus 2 times x over x squared times x plus 2. And if I'm ever going too fast, you are always welcome to stop the video. So let's factor the top. We have x plus 2 over x plus 1 over x squared times x over x plus 2. We can already see stuff canceling out. The x plus 2's are going to cancel. The x is going to cancel one of the x squares on the bottom. So your answer is x plus 1 over x. So some of these are long problems that you really need to be careful because it's very simple and very easy to make a mistake. So you really have to be careful on these problems. If we're using method 2, again, what we want to do is multiply the top and the bottom by the least common denominator of all the fractions. So in this case, again, it's pretty easy. We have x squared down here. We have an x down here. The least common denominator is going to be x squared. So we multiply everything on the top and the bottom by x squared. That leaves us with x squared plus 3x plus 2 all over x squared plus 2x. Again, you're going to want to factor. So you factor by taking the x plus 2, x plus 1 for the top, factor out x to the bottom, so you get x times x plus 2. The x plus 2's cancel, and you're left with x plus 1 over x. So again, this fraction seemed to suggest that method 2 was actually easier. And again, you can choose whichever method you like. Alright, example 4, we have this fraction that you see before you. I would encourage you to try to pick which one to use. You will probably notice that when you have a lot of variables, fractions, it's probably easier to use method 2. So you can try to use method 2 or method 1 to solve this problem, and I will go through them both. So pause the video and resume when you're ready. Alright, if you use method 1, here's what it would look like. You would basically simplify each fraction on the top into one single fraction, so you take the least common denominator of the top and the bottom. The least common denominator on top is x squared y squared. The least common denominator on the bottom is x and y. So if you simplify the fraction on top, you get y squared over x minus x squared over x squared y squared plus x squared plus 2xy plus y squared all over xy. So I just added these fractions and made them into a denominator that was common. So now I will divide the fractions by multiplying them by the reciprocal. So you end up with something that looks like this. And you put it all together, you can factor. So y squared minus x squared is y minus x times y plus x. X squared plus 2xy plus y squared simplifies to x plus y quantity squared. Now all you have to do is cancel stuff out. One of the y plus x's cancels out one of the x plus y's here, because once again, addition, you can switch the order, it's commutative. And one of the x's cancels out one of the x's here, one of the y's cancels out one of the y's there. So you're left with y minus x all over xy times x plus y. So in method 1, simplify each fraction on the top by combining them using the least common denominator, and then divide. Method 2, I think, is a little easier. I think it's a lot easier, actually. So let's multiply the top and bottom by the least common denominator. What do you think that is? Well, it's x squared y squared. So let's multiply the top and bottom by x squared y squared. So if you multiply x squared y squared and divide it by x squared, you get y squared minus x squared on the top, and on the bottom you get this, x cubed y plus xy cubed plus 2x squared y squared. Now we just have to simplify and factor each expression to try to knock out any common factors. So this becomes y minus xy plus x. On the bottom we can factor out an xy, and we're left with this, x squared plus y squared plus 2xy. Again, you should be able to recognize this pattern by now. If you rearrange the 2xy and the y squared, you get a perfect squared trinomial. So this becomes x plus y quantity squared, and we're back to where we were after method 1. You can cancel out one of the x plus y's, and your answer is the same, y minus x all over xy times x plus y. So these problems require a lot of care, a lot of patience, and a lot of perseverance, something that most of you guys have no problem with. If you get tired doing these, feel free to take a break. There's no rule saying you have to do them all at once. So if you feel like a little overwhelmed, you need to step back, take a break. Hold on to the video. We'll have one more example when you're ready. Example 5, we have that thing on the top. So again, if you used method 1, you have to find the least common denominator for the top and the bottom, and then simplify them into one fraction on the top and bottom, and then divide. If you want to use method 2, you can do that as well. So take a minute to try to do that, and if you're stuck or you're ready, resume the video. Alright, we have method 1, which requires you to put everything in the denominator of k minus 2 on both the top and the bottom. So the k becomes k times k minus 2 over k minus 2. This is 1 plus 1 over k minus 2. And the bottom, I took that 1 and multiplied the top and bottom of k minus 2. And now I just combine everything. K squared minus 2k plus 1. This is k squared minus 2k. All over k minus 2. Here we have a k squared plus k minus 2 all over k minus 2. So you can now divide the fractions and multiply by the reciprocals. So you will notice very quickly that the k minus 2's disappear straight away. But you probably would have noticed right here. You probably could have knocked those out. But in the sense of being formal, I'm going all the way. So this becomes k squared minus 2k plus 1 over k squared plus k minus 2. Now you can factor both the top and bottom of the fraction, and if you factor, you get k minus 1 squared times, k minus 1 squared all over k plus 2 over k minus 1. So you can reduce the fraction, one of the k minus 1s will cancel out, and you're left with k minus 1 over k plus 2. Let's go to method 2. We have that monstrosity. We can multiply the top and bottom by k minus 2 because that's the common denominator for both the top and the bottom. So you're left with basically, we skipped a bunch of steps. So you can see why sometimes method 2 is a lot easier to deal with. So k squared minus 2k plus 1 all over k squared plus k minus 2. And you're back to where you were after most of method 1. You factor the top and bottom and you simplify. Alright, so that's the end of section 5.7, dealing with complex fractions. Before class tomorrow, we'll do a couple more examples together because I want to make sure you guys get this before you start tackling the problems we'll be working on in class. If you have any questions until then, please post them on Facebook, send me an email, help each other out.